Hi mathletes, today we're going to talk about powers of 10. Powers of 10 look like this. 10 to the first power is 10, so 10 is a power of 10. 10 to the second power is 100, so 100 is a power of 10. 10 to the third power is 1,000, so 1,000 is a power of 10. Before I get any further, I just want to point out something that's going to be helpful to us later. Notice that 10 to the first power has 1 0. 10 to the second power has 2 zeros, and 10 to the third power has 3 zeros. The exponents and the number of zeros should match up. This is information we're going to use later. So I'd like you to start by looking at these math facts that you know by heart. What is the trend here? I multiply the 3 by 10 and I get 30. I multiply the 70 by 10 and I get 700. Hopefully you notice that in both cases we're adding a 0. We're actually doing something a little bit more precise than that. We're moving the decimal point one spot over. So in both of these examples, I multiply 3 by 10, moving the decimal one spot over to get 30. I multiply 70 by 10, moving the decimal one spot over to get 700. That's going to be helpful when we multiply decimals that we can't do in our heads. So next we're going to move on and we're going to look at some examples with decimals. It works the same way. When I multiply 3 100ths by 10, I get 3 tenths. It's the same thing. I'm just moving the decimal over by 1. Oops, the wrong arrow. Moving the decimal over by 1 to the right. When I multiply 7 10,000ths by 10, I get 7 thousandths. Moving the decimal over 1 to the right. This makes mental math much more easy. Now you don't have to write these types of problems out using lattice multiplication. You could just do them in your head. The work you would need to show is just the arrow. We are now ready to write down our rule. So one rule is that to multiply a number by 10, move the decimal one place to the right. It makes sense. We're making a bigger number when we're multiplying it by 10. What about if we have 2 10s? Now I can move the decimal over one place for the first 10 and move it over one place for the second 10. That would give me a final answer of 549 and 9 tenths. 549 and 9 tenths. Well, we all know that 10 times 10 equals 100. So this should be the same answer as 5 and 499 thousandths times 100. It's the same thing. Instead of moving the decimal over once for the first 10 and once for the second 10, why don't we just move it over twice to represent the 2 zeros in the 100? So because 100 has 2 zeros, I'm going to move the decimal over twice, and I get the same answer, 549 and 9 tenths. That gives us our next rule. I can say to multiply a number by a power of 10, move the decimal place to the right once for each zero in the power. 100 has 2 zeros, so we're going to be moving the decimal over twice. For 1,000, you'd move it over 3 times. So try these. Please pause the video as you give these a try. Hopefully you've already done these, so you can get ready to watch the answers. 1,000 has 3 zeros, so I'm going to move the decimal over 3 times. Now what do I do about these 2 swoops that don't have any numbers? I'm going to drag down a 0. So the answer to that one is 4,500. For the next one, I'm going to move the decimal over twice. And that answer is 9 tenths. It gets moved over twice because 100 has 2 zeros. For the last one, I need to move the decimal over 4 times. There are 4 zeros in 10,000. So that's 1, 2, here's an empty swoop. I'm going to have to bring a 0 in, and another empty swoop. So my decimal point would be way at the end. And this answer becomes 28,700. As I told you before, exponents work the same way. 10 to the third just equals 10 times 10 times 10, which is 1,000. So we would move the decimal over 3 times. We can look at the exponent on the 10 to the third, and that also tells us to move the decimal over 3 times. So in this first example, we would move the decimal over 3 times, and it would end up after the 5. For the second example, 10 squared is 200, that has 2 zeros, and the exponent tells us to move it over twice. So the decimal would end up between the 6 and the 3. I could drag these decimals to the spots that I'm talking about. So that's where our final decimal would end up. For this last one, 10 to the 5th means we need to drag it over 5 times. 1, 2, 3. Going to need to add 2 zeros. And then the decimal would go at the very end. So it'd be 1,890,300. So just to recap, this is not new. When we multiply by a power of 10, we move the decimal to the right of each 10. We're going to remember that as we look at division. What's the trend here? 50 divided by 10 is 5, while 400 divided by 10 is 43. It's the reverse of the multiplication. In this case, we're going to be moving the decimal over 1 to the left. So here we go for our second rule. This is the one we've already done. We've already done multiplication. For division, when we divide by a power of 10, we move the decimal to the left for each 0. So division means move to the left. We're making the number smaller. So if you were to try these, for this first one, we need to move this decimal over to the left once, which would give me an answer of 2 45/100ths. Here for the second one, I'm also going to be moving the decimal over once. Here I need to borrow a 0 to put before my problem, and this one gives me 0 200ths. So again, for division, you move it over to the left by the number of zeros. So try these while pausing the video. When you're ready, press play. Hopefully you're ready. So for 47 divided by 1,000, there's 1, 2, 3 zeros. I need to move the decimal point over 3 spaces. And I'm going to need to borrow a couple of zeros there, and one's kind of going off the page. So sorry that that's going off the page, but I'll rewrite it. So the answer to this first one would be 0 47/1000ths. Again, there's 3 zeros in 1,000. I need to move the decimal 3 to the left. For the second one, 10,000 has 4 zeros. So I'm going to move the decimal 1, 2, 3, and again it's going to go a little bit off the page, 4, and I will rewrite the answer for you to the side. So this one's going to have a lot of zeros, right? So the answer to this one would be 0, and let's see what number this is. We have tens, hundreds, thousands, 10,000s, 100,000s, millions. So this number is 2,706 millions. And I've moved the decimal over 4 to the left. See, these numbers are getting smaller. 47 thousandths is a lot smaller than 47. We're dividing, so we're making the numbers smaller. When we multiply by a decimal, we use the exact same rules as dividing by 10. So multiplying by a decimal is also going to move the decimal point to the left. So take a look at this. 4 and 56 hundredths divided by 10 is the exact same thing as 4 and 56 hundredths times 0.1 or 1/10. When we learn more about multiplication rules, you'll see more of why this is, But all you have to remember is that there's 1 0 in this 10, so you move the decimal over by 1. And there's 1 0 in this 1/10, so you move the decimal over by 1. Same thing here. 87 hundredths divided by 100 is the same thing as 87 hundredths divided by, times 100th. Again, 2 zeros, 2 zeros. So you can still use the counting zeros rule. So to try these out, for this one, 9 hundredths, 1, 2, 3 zeros. I'm multiplying 9 hundredths by 1,000th. So I need to move the decimal over 3. It's going to go off the page. But I know that I'm going to have 3 empty swoops here. Oh no, 2 empty swoops here. So my final answer here would look like this. So that's 9 tenths, hundredths, thousandths, 100,000, tenths, hundredths, thousands, 10,000ths, 100,000ths, 900,000ths. For this next one, I have 1, 2, 3, 4 zeros. So I'm going to move it over 4 to the left. 1, 2, 3, and one more. Going to have to add in 1 0. So the answer to this next one is going to be this. So we have tens, hundreds, thousands, 10,000s, 100,000s, millions. So it's 35,687. And on this last guy, we're just going to move the decimal over 1 because there's just 1 0. So the decimal point is going to be right before the 2. Try these for mixed practice and please bring them into class tomorrow.